Hey everyone! From play-at-home VR games to location-based adventures, many developers have already leveraged Unreal Engine to create award-winning VR experiences for Oculus headsets. With so many emerging opportunities for VR creators, we are excited to announce a new 12-course series, VR Development with Oculus and Unreal Engine. Get step-by-step instructions on how to prepare your content, create interactions and locomotion, implement your UI, optimize for speed, and finalize your project for the Oculus Store. Head over to the Unreal Online Learning portal to get started today and bring those ideas to reality. Virtual reality, that is. Engineers, designers, and city planners are now using digital twins to gain insights for improving services, development planning, traffic flow, and even finding the best position for bus stops. Taking on the monumental task of replicating China's most populous city, 51 World created a complete virtual clone of Shanghai, all 3,800 square kilometers of it, with the goal of continuously updating it in near real time. Learn more about how 51 World was able to generate the virtual clone on the Unreal Engine feed. Previously featured for their innovative work supporting virtual broadcasts at NAB, Fox Sports' NASCAR Race Hub, and at the core of the Weather Channel's new virtual studio, Zero Density's Reality Engine is now available to download for free. The real-time broadcast compositing system enables real-time VFX pipelines featuring video input-output, keying, compositing, and rendering with a single machine. Download the Reality Engine from zerodensity.tv today. When asked to create a short brand film for Epic Games, artist and director Phil Fury and his team at The Mill dove right into Unreal Engine. Get a brief behind-the-scenes look at the creation of the short film Unreal for All Creators and their approach to real-time effects in Unreal Engine. Watch the full spotlight on the feed. Now to thank all of our top weekly Karma earners for helping folks out on Answer Hub. Shout-outs to Everynone, Expos, Clockwork Ocean, Mama Marcis, GeoDVS, Akari, Mahakyu, Cheerer, Evo Cleric, and Cruzy18. Join the adventures of Axel the Axolotl with their brand new YouTube series. The short videos feature an adorable amphibian singing songs and playing underwater. Check them out on YouTube and subscribe to catch their weekly videos. Challenged by a community member, director and graphics artist Wes Ball, known for the Maze Runner trilogy, recreated the mysterious heart of the maze, the Glade, in Unreal Engine. Watch the time-lapse of his piece and follow more of his Unreal activity on Twitter. After the world was nearly destroyed during the Rift War, take up arms to reclaim the surface of the exotic, hostile world you call home. Explore the rich world of Epic Mega Grant recipient The Stranger, an intense VR combat game now available on Steam. Thanks for watching this week's News and Community Spotlight.
Hi everyone and welcome to Inside Unreal, a weekly show where we learn, explore, and celebrate everything Unreal. I'm your host, Victor Broden, and today I have a bunch of amazing developers from the other side of the pond in the UK. I think most of you are. Let me introduce Carlos Ulloa, creative developer, Julian Diedesheim, 3D artist.
Hello, everyone.
Malachi Duncan, technical artist.
Hello.
And last but not least, Saga Alayobi, lead 3D artist. Welcome to Inside Unreal. Today we are going to talk about the Unreal for All Creators brand video that was recently produced for a couple of years. And I think to get started, so that everyone knows what we're talking about, I'm just going to go ahead and play the video.
Creativity lies in all of us. It's what makes us human. It starts with an idea, the desire to create, solve, to play, to share, to interact. Together we can build new worlds. The freedom to create for all.
All right, that's a pretty impressive video there. Was getting a quick report that my mic be popping, so let's hopefully that's not the case anymore. We'll see how it goes. But without further ado, Saga's going to kick off the presentation, and so let me open up the slide for him here. Take care of some of this. All right, Saga, we are good.
So just to give you guys a little bit of an intro on the project. The project was directed by Phil Fury, who's a director at The Mill. Sorry, Victor, if you can just pause it at that slide. So the project was commissioned by Epic and given to The Mill, and our job as a team was predominantly to support The Mill in making this project happen under Phil Fury's direction. And our team was responsible for the opening architecture sequence of the film. So the four guys you see on the stream here, we were supposed to take the architectural sequence from start to finish. So that's pretty much what the focus of the breakdown is going to be today. The Mill also got additional support from a few guys across Epic on the special projects team. So halfway through the project, some awesome artists from the special projects team joined the job and helped take the piece all the way home across the finish line. So the theme of the project was to connect the four main industries that are represented by Unreal Engine. So from architecture to automotive to gaming, and then finally media and entertainment. And it was to unify all of those sectors under a coherent brand campaign. Next slide, please, Victor. So this is the architecture sequence that we were responsible for. The Mill did all of the live action visual effects on top of the Unreal Engine renders. So what we provided were finished Unreal sequences that had to work and align with the live action shoot. And we'll go through the process of how we constructed all of the transforming buildings, the twisting city, all of the cool effects that you see here in the architecture sequence. So that's going to be our focus today. There's a few more shots here that weren't in the final film, but just to give a little bit of more detail on some of the environments we built.
Yeah, they're impressive shots. It's cool to see a little bit of some extra footage.
Thanks, man. Yeah, next slide, please. So the first thing we received was, next slide, please. First thing we received was some previs, which was done by the Third Floor VFX in LA. So this was entirely done in Maya, and we received these playblasts from Maya as kind of a guidepost for the final film, and we used them to guide kind of the overall concept as well as the timing of the shots. Some of the compositions you can see were already established before we even started any Unreal work. The bones of the project were already here in the previs. But what we decided to do was actually we didn't take any of the assets or cameras or anything from the previs. We just kind of used this as a visual representation, but on the Unreal side we started from scratch. Here you can see the storyline, the gaming section, the robot from Robo Recall, crashing through the columns and transitioning over to the final media and entertainment section, which is like AKA film, television. The concept for this section was actually initially to have a LED wall behind a live action character and have the environments within the LED wall change, representing, real-time technology and used in conjunction with LED walls. But there were a lot of constraints with the live action shoot that prevented that from happening, so we had to find kind of clever workarounds with that section. Next slide, please. And next slide. So this is the live action plates that we got from Phil and his team in LA. The crazy thing about this was the shoot happened literally the day before the COVID lockdown went into effect in LA. So there were a lot of constraints in terms of like safety measures on set. They didn't have time to do any reshoots or anything. So we really had to work with what we got on the day without any opportunity for flexibility down the road. Kudos to them for capturing all of this footage in under such tight conditions. But we managed to make it all work in the end, and I think it was quite successful. A lot of bits obviously were cut out of the final film, but still a lot intact as well from the live action and the previs. The important thing in this project as well was that we tried to achieve a level of fidelity that was similar to what you would get in offline VFX. So, our Unreal scenes weren't necessarily running at optimized frame rates by any means, but it was just to get that look of kind of live action VFX CG in real time. Next slide, please, Victor. And next one, please. So alongside all of the previs and the live action plates, what we got from the director as well were these mood boards. So for the architecture sequence, a lot of the mood boards were pulling from Inception, Doctor Strange, kind of this idea of a surreal world being transformed by a lone figure. Next slide, please. So you can see here ideas about, this lone figure manifesting the city through his imagination, and kind of buildings emerging from wireframes, from out of wireframes, and kind of checkerboard non-shaded buildings into fully realized cityscapes. And then the city begins to transform and ripple and twist and have all kinds of like surreal transformation. Next slide, please. Again, more images provided by the director just for our reference. And then next slide, please, Victor. So the idea, I think, for the automotive section was kind of a abstract sculpture. If you look at the director's personal art, like a lot of his art has these really intricate, multi-array complex sculptural forms made out of like car parts and sneakers and all kinds of things. So he took a little bit of that design language into this section. Next slide, please. And again, next slide, please. And then transitioning from automotive into gaming, he wanted to pay homage to some of the stuff that Epic had done in-house in terms of gaming. So some of the amazing robots from Robo Recall and the Chaos demo, interacting with the live action figure from the live action shoot. Next slide, please. You can see the concept here is that the girl is running through this massive museum, and as the robot smashes through the museum, he begins to disintegrate into these particles of dust, and using the dust particles to transition into the sandy environment, which is kind of a Mandalorian-inspired environment for the film, media, and entertainment section. Next slide, please. Just a couple more images there from the media and entertainment concepts. Next slide. And again, the idea here was to kind of reference all of the amazing LED wall technology that Unreal is now starting to become quite famous for. So we kind of tried to, express that through the final film, even though we weren't able to use an actual LED wall on the shoot. I think the idea still kind of comes across. So next slide, please. And so beginning to gather reference, the director wanted a really minimalist look for the architectural interior. So we pulled a couple of images and pass those along to see if they were to his liking. And so he wanted something kind of a bit minimalist, modernist, and have most of the section be carried by the city itself. So next slide, please. And what I think he wanted to go for was a kind of a magic hour, very heavy volumetric fog, atmospheric kind of moody look to the city. So these were kind of the images we used to guide some of the work we did in Unreal. Next slide, please. As far as the city itself, there wasn't any one particular city we wanted to reference, so it was just kind of a mishmash of a ton of modern cities. So we ended up modeling variations of cities that you see throughout the world to kind of create our own city. Next slide, please. And then an important part of the story was that this architect in the apartment is actually creating the city. As he looks out the window, he's actually beginning to create the city out of his imagination. So, looking at something like the intro from Tron Legacy, where these lines begin to converge and create the shapes, and then eventually the wireframes coalesce into physical building forms. This was kind of something along the lines of what he wanted to go for. Next slide, please. So the way I like to work in Unreal is we didn't have necessarily concept art to kind of guide the look of the city. So there was a lot of creative freedom on our side to really express ourselves as artists and just, design these shots and conceptualize them and then present them to director for his feedback. So it's really this idea of the fast iteration time of design and look development in Unreal, using it the way a concept artist kind of works. And that's kind of how we created some of these shots to begin with. Next slide, please. So here you can see like the first week, the really, really early development. It was just about, taking some marketplace assets, blocking out scenes with really, really rough layouts and lighting, putting some shots together with some really simple camera moves, and just starting to establish a sense of scale and a mood. Again, all of these are like assets we got from the marketplace and things. So it's just about the speed of iteration, like how quickly can we come up with a starting point for the design process that then we could start to build upon down the road. And some sections still hadn't really been worked on beyond the previs, but you can see a little bit later. We also worked on some of the media and entertainment sections already within the first week. We had an idea about what the desert and the rocky environment and the forest might start to feel like as the piece evolved. So, you can see how quickly with Unreal we were able to get ideas on paper and in front of the director. That was a really fun part of the process. All right, next slide, please. Again, so one way I like to work is to go back and forth a lot between Unreal and 3D modeling and Photoshop. So, I'll have a scene in Unreal, I'll take it into Photoshop, sketch over it really quickly, and then that will give me like 2D elements that I can bring back into Unreal on cards, like things like atmospheric effects, dust sheets, sprite sheets, things like that. So I'll go back and forth between Unreal, Photoshop, and 3ds Max and Maya a lot of the time to work up these scenes. Next slide, please. So you can see now from that early sketch, this is the next version of the scene in Unreal in the second week. Already starting to get a closer feel for the environment interior, the apartment interior, and also bringing in the plate on a 2D transparent card directly within the engine. I think it skipped something there.
Trying to find it here. All right, there we are.
No worries. Yeah. Okay, so as we were developing the city, we started to model a lot of custom buildings. And the awesome thing was how quickly... I think it's...
Sorry, Saga. Yeah, it's jumping to its own position in the playlist.
No worries. It's probably my bad. Yeah, so you can see like some of the buildings we modeled, we're able to, in 2 clicks, bring them directly into Unreal and start to get a feel for whether or not they fit the feeling of the city, the composition. So just again, that really quick back and forth between modeling and Unreal was amazingly powerful to see it right there. Next slide, please. Here, I was starting to think about ways that we could, transform this large grid of a city. So, we really didn't know what we were going to do as far as like the city twisting and rippling. So I did a few experiments that I passed along to Carlos to kind of, see what we liked and what we didn't like about these little experiments and figure out a kind of a guiding visual for something that Carlos would then later create in a shader and in blueprints in Unreal. So these are just quick little tests in the process. Next slide, please. Again, the same test, just with a little bit of lighting in it, just to get a sense of, what we might like to try in Unreal. So as I was doing these, Carlos would be doing basically the same thing, but in blueprints in Unreal. So we could really start to see what is doable, what's not doable, and how easy it is to start to bring some of these experiments into the engine. And then while Carlos was building the blueprint, I was simultaneously bringing sort of static versions of these tests into Unreal to figure out, kind of the mood and lighting if we did have these massive cities overlapping. Here, this is replacing them, the cubes, with static meshes from marketplace assets we got. So it's like really quickly early on, just trying to, conceptually work to slap together these scenes and figure out what it might feel like to have this massive amount of buildings that were spiraling on top of each other and folding on top of each other. So the cool thing is, I think this was even the second week of working on the project. So very early on, we were able to get a sense of what it might feel like. Next slide, please. Again, a few more tests of other things to try. Potentially the city would not just twist, but also have a little bit of a ripple. And I think in Carlos's final version, he was able to actually have a ripple effect. This is now starting to work with the blueprint that Carlos actually built and test it in Unreal with cameras and lighting in the engine. So this is the first version of the blueprint, and it allowed us to find what was working, what wasn't working, and kind of inform the different ways that the blueprint layout would distribute buildings across the city, and then also how the twisting effect would work. So I think this was, again, really early on, like the third week of the project, but already we could start to see something resembling what ended up becoming the final effect. And here's a little bit further on in the process, a little bit closer to the end when we had a bit more detail in the city. You've also got the growing buildings along the side. And after I talk about all of this kind of high level art direction stuff, towards the end of the live stream, you'll hear from Carlos and Malachi as well in depth about the different shaders and things they use to actually create these in the engine. So, we won't leave you hanging. You'll have a little bit of information on how to do this yourself as well.
Awesome, man.
Just lots of different tests. The cool thing about Unreal is, we can try different cameras very quickly in the same day, have different lighting scenarios, different speeds. Yeah, we tested out a lot more than what you saw in the final film. Here's, a few versions of shot 6. Oop.
Sorry, Saga, it's skipping on its own here.
No worries, man, no worries. Yeah, I figured we'd run into speed bumps in the process.
The autoplay in VLC here is it's what's ruining me right now.
Yeah, no, it's all good. It's been pretty smooth so far.
Yeah. All right, I think we're at here we go.
Cool. Yeah, so this was, again, another concept I just did in 3ds Max to think about, how we might have the building growth effect. And, once I showed this to director, he was pretty happy with it. We had to figure out how to do it in Unreal. And Malachi came up with this ingenious way of doing it using Pivot Painter. So he's going to go through that a little bit today, but then also in a webinar next week where he's going to go in depth on how you can create buildings that transform the way that you see in our film using Pivot Painter with 3ds Max in Unreal. These were some early tests of a shader Malachi created, which allows you to have this parallax effect on the inside of buildings, kind of like if you played the Spider-Man game on PS4. So these are just cubes, but there's a parallax shader on the windows that gives the illusion of an interior. And then just testing them in a scene to see, how close to the camera they hold up, and when we might need like actual geometry instead of just the parallax effect. So again, a lot of testing in our process. Next slide, please. So this is, again, going back to how I was talking about working within Unreal as a concept artist. So once the blueprint for the city was developed by Carlos, if you can just pause it here real quick, Victor, and maybe play it again. So I started to test a few different camera angles and, rendering out a few different versions. And then just directly in Photoshop, I would play around with different atmospheric effects and like layering things on top and figuring out different vignettes and lighting and atmospheric elements. And I would use those to inform what I would then be doing in Unreal. So I would take a lot of these elements into Unreal as sprite sheets, as cards, and just start to overlay them. And you can see, I think in the next video, you can kind of see that all coming together in Unreal in the shot. So, the back and forth between concepting in 2D and then working directly in Unreal with the 2D layers. I think this one is just talking about a little bit of the modeling process, laying out the city. So just can skip through this one. And again, this is working out one of the shots where there was a car driving through the city, just some layout stuff, and then also figuring out how to work the camera and the car together and refining the car animation. So a little bit of back and forth there. Early versions of this shot had some UI overlaid on top of the city, which later got canned, but you can kind of see a little bit of the early development of this shot here. Next slide, please. And I think you can just let a few of these play through, Victor, because they're mostly just different versions of the same shot, just with slightly altered car animations and slightly different camera angles as well. We had a lot of fun with this shot. I think this is probably our favorite shot to work on because it brought together kind of everything. So I think that was very much a team effort on that shot. The other thing I want to talk about, if you can just pause here real quick, Victor. So one of the challenges of working with the VFX pipeline and the whole live action element is we had to make sure that the lighting of the CG scene matched the lighting of the plates that we received. And it became important early on to, we figured out that we would need a digidouble in the CG environment in order to figure out exactly how the plate was being lit and make sure the environment was lit exactly the same way as the live action plate we received. But then on top of that, we also needed the character to be able to cast shadows into our CG environment. And because the sun angle actually moves in some of the shots, we needed those shadows to be fully dynamic. So his shadow moves across the furniture in the scene, and also his reflections in the final film. You can actually see his reflections in the mirror, and so we needed the digidouble to be reflected in the glass in our scene as well. So if you play through the video, Victor, you can see here this is like the unstabilized footage laid on top in Unreal before we started to have the digidouble in place. But over the course, this was kind of initial lighting explorations of the apartment scene before we really started to think about the integration of the live action. So as the mood was evolving, we started to think about, okay, once we've got this dynamically lit ray traced scene with movable lighting, we can now start to think about accurately placing the plate into the scene using a digidouble character. Here you can just see the dynamic lighting. So I went into ZBrush one weekend, did a quick sculpt of this character, and it didn't need to hold up because we were just using him for shadow casting into the scene, and then parts of his legs would be used because the plate didn't necessarily have complete coverage. As it moves back in space, you can see the plate is actually cut off. And so for parts of the final comp, there's sections of his legs which are actually the digidouble from the digidouble asset. So here you can see the live action plate brought into Unreal on a green screen card. And then you can see the 3D digidouble placed in the scene, and how his legs were used for the kind of contact shadows on the ground, and then also his reflection in the wood parquet floor, as well as his shadow cast across the scene. So all of that stuff was pretty critical to the integration of the plate into the environment. So in the very first shot in the film, you actually see him from the front, and we had to place him behind the glass. So I ended up projecting the 2D plate footage onto the front of the digidouble character to achieve kind of the first shot in the film. Here you can see some of the shots without the live action elements. These are the back plates we provided. And then in the next shots here, you can see the final comp with the live action element and his reflections and shadows in the scene using the digidouble for shadow casting and reflections. So next slide, please. There you can see on the left is the initial version of the scene, and before we started to think about integration, it was kind of all over the place because the scene was very backlit, but the plate was very much more side lit. And so once we started to get the digidouble in there and accurately light the scene, the mood of the scene changed quite a bit, but I think the end result worked out quite well. Next slide, please. Here you can see if you look closely, you can see actually the reflections of his hands in the glass, and also you can see in the glass you can see his shadows in the scene as well as the reflections of his legs. So all of that stuff, it was really important to have this asset in the scene. And again, the moving shadows as well cast across the furniture. Cool. So next slide, please. So this is the final shot of the architecture sequence transitioning to automotive, and this was the kind of the week one initial block out version of this shot. So once we were happy, next slide, please. Once we were happy with the composition of the foreground elements, we needed to really start to think about detailing this foreground, as the camera would get really close. And so the next presentation right after mine, Julian's going to go through some of the details on how he used a lot of Megascan's assets and customized those assets to fit the composition and curvature of the road in our scene. So next slide, please, Victor. So this is the final shot, and you can see kind of the level of details we managed to achieve. Julian's going to go over some of the detailing work on this scene. That's a wrap for my section.
All right, thanks, Julian. Oh, Saga, Jesus, I'm so up in the playlist here. Make sure I play the right video, pausing in, making sure the right window's in focus. That's really cool. Thanks a lot, Saga.
Appreciate it, Victor. Thanks, man.
All right, let's go ahead and get the right stream started here. Let's see, Julian, you are already up and running? Yes.
I think so, yeah.
Perfect, you're good to go.
Can you see it?
Yes.
Yeah, so hello again. So I'm Julian, and on this project, I was responsible to create environments and provide props for the other artists. So today, I really want to show you a pipeline, an art pipeline, how to use Quixel and the Quixel Megascan as a strong base to be quicker. So one of the main challenge of this project was to create realistic environment and props within a very short amount of time. And to do this, I heavily used Megascan as a leverage tool. What I mean by using it as a leverage tool is it is so easy today to just, take Quixel Bridge and just drag and drop props or textures within Unreal, and you get great results. But at the same time, I've got the feeling that you can kind of lose the authenticity of your work. So I've got a feeling that the more we go forward with Quixel and Unreal, we're going to try and to see some artists using Quixel just as a base, and then leverage the quality of Quixel to be faster. So I want to show you guys. So this is one of the shots I worked on with Saga, and Colors and Malakai, of course. But the thing I want to talk about specifically is the concrete barrier on the side. You can see it here on the left-hand side. And I'm going to show you how I take some scans from Megascan and create some modular asset out of it. So first thing first, as Saga said, reference is super important for us. Even if you're going to use stuff like that, make your background work. So in the center of the screen, you can see this is the blockout from Saga, what I had when I started. And the goal was really to improve the quality to the best we can. The most important part here of the reference is on the right, top right corner. So with the barrier. Next, I would jump. So when my reference is done, I would jump within Quixel Bridge and try to find the reference and the scan story that I need. Here, the concrete barrier was perfect for me. Whenever you want to work with a 3D asset in Megascan, I highly recommend using the high poly source. So you can see that I've ticked the box in bottom right corner. That will give you the best quality out of the scan. Next, I had a closer look at the mesh, and the first thing which pops out to my eye is that those holes at the bottom will not work with what I wanted. So if you check this image, if I had those holes, I would have a very repetitive pattern, which would have not worked with the feeling and what we wanted to create. So first thing to do was to actually fill in those gaps and fix some heavy scratches which were a bit too heavy on it. So the way I did it is to simply import my mesh in ZBrush. So here you can see this is the rough scan straight off the Megascan using a texture, as you can see here. And my first goal is to project those textures on Polypaint. So to do this, you need tons of polygons. So I am duplicating the mesh, and I'm going to subdivide my mesh 2 times. So I'm going to get a crazy amount of polygons, but it's going to be all right. So I'm going to go up to 24 millions. And then at this point, I will project my texture to Polypaint, so vertex color. As you can see it here. So now you've got a mesh which is pretty high poly, but the texture, the albedo texture, is on the mesh, on the vertex, so it gives you full flexibility in terms of what you want to change, what you want to tweak, and you can add stuff, and etc. So here you're gonna see a very simple fix for this. I'm gonna duplicate the barrier and simply move it to fill in the gaps. There you go. That's simple. The gaps are filled. And now it's just a bit of cleanup. So I will delete the top part, the sides. And yeah, anything you want to do to improve the high poly, it's now that you can do it. And then at the end, for me, the most important thing is to merge the different component into one and make one Dynamesh out of it, which you will see in a second. So still a bit of cleanup. I think that's fine by me. You've got everything you need it. And this is the final mesh. Yeah, one Dynamesh, all cleaned up, ready to be exported to Maya to create a low poly. Next, so this is pretty standard. There's nothing fancy here, but this is just the way I work. So I've imported the concrete barrier within Maya. I've created some metallic parts as a high poly, and I've split them apart for the baking. So, and then from there, I will create a low poly mesh that you will see in a few seconds. So this is the low poly. I'm making the low poly very modular, so I'm going to be able to really repeat the concrete wall and to make a really long wall out of it. So I'm merging everything onto one UV to keep it simple and clean. And within Substance Painter, I am going to work with this mesh so I can have, the duplication of my UVs visible within Painter. Next, we are in Painter. So here I've already done a simple bake. You can see my normals and my AO. It already works great. This is a great base to start with. Next, the little trick to know is that when you bake your maps, what you can do is you can bake the ID map and use it to bake the vertex colors. So that will allow you to, this will allow you to actually get the albedo that you got from Megascan. You can see it here. And this is the result. So I'm using that texture as my albedo. Then it's about, having fun with it, cleaning up a bit the texture, changing some values. I'm doing the same thing with the roughness. So I'm simply transforming my albedo with a grayscale, adding some mods, a few more details for the metal. And then when everything seems fine, I will just check the PBR values with the PBR validate. Everything is green, everything is fine. So Unreal can work with it and it's going to look good in the engine. Next, I'm in Maya. And so as you remember, I received the block out for the road from Saga. And my goal was to take my concrete barrier and make it follow that road, same as a tunnel. The way I did it is to take the road and create curves out of the geometry. So this is the curve which is following his geo. And then from there, I simply took my wall, make a really long one, so duplicate it. I've duplicated quite significant amount of time, so it's going to be quite long. I've put it in the center of my scene, killing the history and freeze transformation, makes it all clean and tidy. And then on this one, I'm applying lattice or FFD and a curve map. So that will allow me to follow the curve. There you go. So that my first base is done here. And then the next goal is to have the wall following the curve and the road with right angles. That's where the FFD is really useful. So yeah, there you go. You can see that the wall is rotating in the right angle. It's a lot of manual work. There's no cheat about this technique, but you get the result that you want. And this is the end result. So this, you can see my FFD here on the right. I can still control the angles and have exactly what I wanted. There you go. So when that was done, I then import my mesh in Unreal, and this is the end result. So the setup is there's nothing complex in this setup. So I've got my mesh with my textures. I'm using some decals to get more details in. Here you can see my wall. And if you check my shader, nothing super complex. So we always work with a master material and this is my instance. So I'm adapting the values. So the material works great for the shot. And again, so you can see it's not a super complex mesh to create, but Quixel really allowed me to create this highway very quickly. I think it took me something like a day and a half maximum for the entire piece. And if I had to make it all by hand, model it, make my high poly texture, it would have taken probably twice the amount of time. So again, Quixel, super great to make shortcuts. Next thing, see if I can find where is it? Yeah. So here I'm going to give you another example of how to use Megascan as a leverage tool, but I'm going to talk more about the texturing side. So this is a second scene I worked on, the forest. Everything you see here in terms of foliage was taken from the Megascan library. The trees were from the marketplace. And yeah, I think that was mostly it. So here the main focus is going to be on the ground because the camera was so low. The ground needed to have some details in it. But when you use ray tracing, the displacement doesn't really work at the moment. So we had to find a solution to really get that bumpiness and the details in the ground. To achieve this quality, we couldn't rely on normal map or displacements, so it had to be geo. And the way to make that details in the geo was to create those kind of cylinders and apply a Megascan texture, to use a Megascan texture to actually generate that geo. So you can do this in lots of softwares. There's tons of different options around to do it. But Quentin Marmier, which is one of the members of the special project team, created an awesome Houdini tool to speed up the process. And I'm going to show you quickly how it works to give you an example. So you simply pick a Megascan surface, download it, get the file. So I'm going to get the folder spot on my computer and then bring it into Houdini. And then Houdini will look for the textures and the textures he needs to generate the mesh. So as you can see, it's already there. And Quentin has prepared this tool to be usable with different type of mesh. So after the process, you will be able to see all the different mesh available. So there's the square one, and then there's the cylinder that I used. So there you go. All geo, no cheat, no normal, no displacement. Really quick and easy to use. So yes, so that was again a second example on how you can really leverage Quixel to speed up your process and keep the quality really high. Yeah, so I highly advise any artist out there to give it a go, take the time to explore what's possible with that incredible library of asset, and just try not to just drag and drop. It will make you a better artist in the end. But yeah, that's it, Victor. That's it for me.
Thank you. That is great stuff. All right, I believe next up is Carlos.
Yeah, let me share my screen.
Do you want to go ahead and stop your share, Julian?
Sure.
Just save a little bit on the potential
Cool.
bandwidth.
Can you see this?
Yes.
Cool. Basically, my job here was to make in Unreal using only blueprints. We wanted the project to be blueprint only, so it was kind of accessible to everybody. So I did the city, the Twisting City. The way we did it, we basically, let's turn this off. We started with this template because the idea was initially we laid out the buildings randomly just to make the first tests. but we realized that that wasn't looking like a city. So I made this little city generator where we have a number of blocks like these ones here, and each one of these is later replaced with different buildings. So we basically have 4 types of buildings: the skyscraper in cyan, the orange ones, the smaller ones, and then the pink and the red ones, much smaller. And the way it works, we basically have, this is an example of how the city is laid out. Let me put it a bit bigger like this. And you can see how this is generated. This is randomly generated. So we could come here and change the seed. I will generate like a different layout for the city. And this allows us to basically get the feeling of the city and the ratio between bigger buildings, smaller buildings, the way we want it. The way this works is actually done all in Blueprint. And it's all the parameters. We have a few parameters here just to control the size. For example, we could make it bigger like this, or we can make it smaller. So we can have the size of the city being completely dynamic. But ideally, we wanted to create a city that we could control with a set of parameters. So everything is controlled with a data asset that you can see here. So it's much easier to manage all the settings, all the different settings in a data asset. That's basically an external asset that's here on the content browser, instead of having all the parameters here in the details of the actor. So if you look at the parameters that we have here, we have on one side, we have all the classes that are basically the different blocks and the different layouts of the city, of the different blocks that we allow in the city. And then we have the different meshes that basically we use to replace the placeholder mesh that we use for previews, basically. And then we have the parameters that define how the city works. If you look at this example here, if we replace this set of parameters with this one that I was using as a test, you can see how different it can be. This is the most basic test, where we have just the same thing, but it's only using the most basic set of parameters. I can go quickly through it so you have an idea how it works. Basically, we have a random range, which basically adds some random to the city. So at the moment it's 0, but if I add 1, you will see that it basically randomizes the whole thing, which is not what we wanted. We wanted to create the feeling of having some places which look more like downtown, and other places that look more like lower, like neighborhood areas. So we basically added a bit of randomness here. You can see the difference between having 0 and having just 0.1 is what we used on the final one. Then we also added some noise. The noise is also really important, so we can actually get a bit of randomness. So the blocks don't really appear close to the city center, but they appear with a bit of randomness as well. The number of centers is also something that we play with. Here we have only 1, so you can see everything is defined by this point here, but we ended up having more than 10. So when you render, you can see how, in this case, it doesn't work like that. But if you render this one, you can see how we have the different centers here, and there. And basically, by playing with those, we were basically able to model the city first using this layout mode, which we call previews, where we can see basically how many tall buildings we have, how many small buildings we have. We also added some settings, for example, just to make the city less. If you look at it here, you can see how it's not aligned. The roads are not that aligned on the lower height areas, while if you look at the city center, they are perfectly aligned, all the streets. So we added a parameter for that, and then we added some curves as well, so we can define the ratio. If you come back to the demo asset here, This system of using the data asset is very flexible, just to swap out parameters and make sure that you can play with the parameters without breaking anything. You can see how can we, this is the linear curve, but if we use something more elaborate like this one that we created, in this case, this is going to be the tall buildings and these are going to be the smaller buildings. So we're going to have very few tall buildings compared to using this way, in which everything is like they are more evenly distributed, which we didn't want to happen. So if we look at it here, you can see how the tall buildings are concentrated on one point and the smaller buildings happen to be around it. Then we have a few parameters just to control, for example, the size of the roads. We could increase that a lot without basically changing anything. You can see how here we can make the roads wider, or we can change the size of the blocks, or even the number of the radius of the center. So if you have like, this was like, let's say 50,000, you will see the difference. That is much bigger. If it was like 100,000, it would be even much bigger. So by playing with these parameters, we were able to model the city dynamically, and the city could be huge in size. It was much bigger than any city you would see, because you end up adding buildings and suddenly you have miles and miles of buildings. And then once we're happy with this, we have a parameter here that when you check it out, then you can replace that with actual buildings. In this case, just replace with cubes, but you can see how the city looks. And it was looking much more like a city instead of just the buildings randomly placed. So once we had the city more or less working, the other challenge was to make it twist. And to twist the city, there were basically two elements. One of them was the ground. You can see the ground here. And how do we do this? Basically, this is using work position offset. And you can see here in the material how this is basically using the work position offset node. And everything is created with this function. So the way this works, this function is actually generating different outputs. The most simple output is just the work position offset. So that will basically move the vertices to a different place. So that's why you get the effect of the twist, or we could get any effect really. Basically, we have a function, which is this one, and this is where the deformation happens. We can customize that function and have like a different type of deformation, and then we will still, again, we'll get the work position offset, and then we also get the object work position offset and the normals. If you don't, when you use work position offset and you basically change the position of the vertices, then you won't get the lighting right unless you also fix the normals. So in this case, we were fixing the normals on one side, and then we were creating the vertices on the other side. And finally, we did the same with the buildings. In this case, the buildings are different because the buildings, they don't actually bend. The buildings is only the position and the center of the building, which is at the base. That's what is being moved around, but the buildings themselves, they are always straight. And to do that, we use this technique. Here, when we are doing the ground, we use the local position of the vertex. So all the vertices are deformed in the same way. On the other hand, for the buildings themselves, what we did was using just the center of the pivot of the building for all the vertices of the building. You can see here how the building is rotating here. And it's not deforming, it's just basically rotating from the pivot. And to do that, what we did is the same function, but instead of instead of giving it like we did with the ground, instead of giving it the local position, which will give it the vertex position for each vertex, what we give is the position of the instance of the pivot of the building. So basically, we are giving one position for the entire object. To do that, you could do it using the position, but we're using mesh instances to make it really efficient and really fast. So what we do is that we use this per instance custom data that this was recently introduced in the engine not long ago. Initially, it was difficult to have a specific custom data for each instance, but with this, you can see how, if we look at the instances here, you can see this is the, for example, this is these buildings here, and you can see how there are 51 buildings of this type, and you can see all the instances here, and they have, each one has its own transform. You can see that the transform doesn't move. And for example, we look at the first one, is this one. But if you look, we also have the custom data. This is hidden in advanced display. So you basically click here and you have the custom data. Here you can add a number of floats for each instance. In this case, we added 3. So we have basically the position of the pivot. And then you can have basically the same position I have here, 9999 0.16 is the same position I have here. So that way we could give to each instance a specific data, and then we could do that in the material in a different way. This is really useful if you have instances and you want them to look different. You could send color values, or you can send any kind of value to each individual instance, and you can update this directly from the blueprint. So when we generate this, I think I can show you how it works in the blueprint. You can see how we use this node, and this is what's adding the custom data value to each instance. So when we create the instances, we basically add not just the transform of the instance, but we also add the custom data value for the instance. And another trick, just to make it fast, is instead, when you're working with mesh instances, instead of updating one by one, you can use batch update instances transforms. Even from C++, I use this all the time instead of updating instance by instance. And this way, everything happens in one go in the engine. It's not that you update one instance and then you have to update the next instance and then you need to mark dirty at the end. You basically do it in one go, and it's much more efficient when you're working with instances. And in our case, we had this huge city, and the only way to do it was using instances. And finally, you can see how by, let's generate this one again, how you can see by basically changing the deformation function and keeping everything else the same, we can have a complete different effect. I'll show you how this works. If you look at this is the deformation, and this is the deformation that gives us the object, the mesh WPO, which is the work position offset, object WPO for the buildings, and the normals. And basically, this is using this function here, and this is where the math for the deformation actually happens. And here we have 2 options. And where is that being opened? Here. We can do twist, or we can also do wave. And we can include any number of options here. And this way, because we use this deformation to calculate the normals and to calculate the displacement of the vertices, basically, we can choose to use this one or this one just by having a static switch. And then we can select which one do we want. And if we want to play with a different formula, we want to make changes, again, without breaking everything, we can create a different deformation function and replace it here without having to change how everything works in different parts of the material. If you want to see the twist function, it's not that complicated. It's basically taking the initial position and then applying, basically finding the angle between The way the effect works basically is by having the x-axis as the front axis, and everything is spinning around the x-axis. Basically, the x value is the same, and what changes is the y and z value. So we basically find the angle between them and the distance, and that will give us the radius, and the angle will give us the angle, and then basically we can use basic trigonometry to find the new positions that after being rotated. So we can find the cosine and the sine, and basically take the multiply by the radius that we found here with the distance, and basically we create a new position. And this is used in different places. The wave deformation is actually simpler. It's basically just taking the initial position and then calculating the radius, and then just doing a sine wave here. Really basic, just multiply by a number, by a parameter, just to check the amplitude. So that was how this works. Initially we did it in Blueprint, but we ended up doing it inside the material. So everything runs on the GPU, and it runs in the editor without doing anything, without even playing. So that's how the city spins. And the other thing that I wanted to show is how the sculpture could be done in Unreal as well. So for the sculpture, it was initially done by the guys at the mill using Cinema 4D, using the cloner tool in Cinema 4D, which is great for doing this type of work. Let me close this one. Here for the sculpture, the idea was to do it in Niagara. So this is a bit of like not the standard way of using Niagara, but it's very powerful for doing this. The idea here was to have, instead of particles being created and being destroyed, we basically have a Niagara system that we can see here, where the meter is set up to basically loop forever and the particles are not being destroyed. So what we have here is, you can see here that the particles, the loop particles lifetime, which basically means that the lifetime of the particle is being looped all the time, but the particles themselves are not being destroyed because of the settings we have on the meter. So in this case, we basically have these cubes rotating, and it's the same cubes. No new cubes are generated, no cubes are being destroyed. And this is basically a burst. So we can have like many cubes, or we can have as little as 4 or 5 as we wanted. And here what we are doing, again, is not the standard way of using Niagara, but it's also very interesting because we're not using any of the dynamics or the physics in Niagara. So we're not using forces. Normally when you have like a normal system in Niagara, what you have is you normally add velocity and then you add forces like here, and then you solve forces. And this node, this module is basically what compiles all the forces and puts them together and basically calculates the position of the particles. Here, basically, I remove this and remove all the velocity, all the reference to velocity, and all the references to forces. I'm calculating the final position directly. So what I'm doing is at the beginning, I have a few custom modules. This one, for example, what it does is it's basically 0 the position of the particle, 0 the orientation, and basically keep the scale as 1. And then on every update, I'll calculate the position based on the lifetime of the particle, but I don't use the previous position, which you normally do when you're doing particles. In the usual way of using Niagara, every next position is calculated by taking the previous position and using the forces applied to the particle to calculate where the particle is going to be. But in this case, we're calculating it from scratch. So the first thing that we do on update is to 0 the transformation of the particle, and then we can add some, in this case, we're adding some rotation and some position. If we take away the rotation, you can see that this is just the cubes being spawned and then being rotated in the same place. If we add the position, then they are farther apart. You can see how we can, let's add more, a few more. And then we can have the position, and we can increase the position and we decrease the position. And this is done in local space. So first we rotate and then we calculate the position. So because each one is rotated slightly differently, then they all basically move in radial form and they create a circle. So that was the initial concept of how are we able to do this in Niagara. Is the two concepts here are, one is to use the spawn burst instantaneous to create any number of particles and set your emitter and the particle lifetime to never die. Basically, you're keeping the particles alive all the time. And then you don't use any forces. You basically calculate the final position of the particle yourself. Once doing that, you could start adding rotation. In this case, we simply added more rotation to the particles. They are added on different axes. To add this position and this wave effect, again, is a sine function. So what we're doing is rotating to one side and then going back to the other side, and then again to one side and back to the other side. And then we have these different rotations happening with different values. This is done with a very simple node, very simple module here that you can see that basically gets all these parameters, the wave parameter for the sine function and the value that we want to use, and then it calculates the new rotation. We have one module for the rotation, and then we have another module for the position and another module for the scale. So we are able to use this wave function on each axis of the position, each axis of the rotation, and globally for the scale, because I didn't want to scale non-proportionally. And this way we could create like different wave values for the different axes, which is what gives the effect. It's nice look. This is the same example, but this one is just with much bigger cubes and changing the size more frequently and having 3 emitters. So the difference here is that we have 3 emitters here that are basically the same, and they keep on moving the different objects. In this case, cubes, but we'll see farther on that you can change to different objects. This is just the out circle, and then you can see another emitter with more cubes, and then another one. And by making them slightly different and making sure that the periods of the waves are not going to match, basically you use numbers that don't divide by themselves. I use, like, for example, I could use 40, 18, and then 18 again, but you can use 17, 6, all sorts of different numbers. So you're making sure that the whole effect is running, and it could be basically running forever without doing the same thing all the time. And finally, you can get an effect like this by replacing, basically the same effect as before, but replacing it with the automotive parts. In this case, we wanted the idea was to have the sculpture made of parts of the car from the video. And you can see how the whole thing is working here. Again, it's the same thing, the same principle. It's just the 3 emitters and doing the same effects per axis. So here you can see how I can select the different axes, and then I can give it a value. I can give it how much the wave is going to be, and how it's going to rotate, and how often it's going to come back to the initial position. And finally, another example I did was this one, where you can see how by having, you can see that even if we keep the emitter the same and the values the same, just by changing the shape, it looks completely different because the shapes kind of overlap each other. So the final effect is always different comparing this one with this one and the cube. So that's worth just once you have the effect working, just playing with different shapes just to see how they look on the final composition. And that's probably it, the sculpture and the aesthetic.
That's really cool. Thanks, Carlos.
Thank you.
All right, let's go ahead and move back. And then I believe it's, last but not least, it's time for Malachi. Oh, something I wanted to mention while Malachi is getting his stream up. We are going to release the project, right? We're going to make the project available to the public. That's correct, right?
We are going to make available some parts of the project. What I show, the city and the sculpture, is going to be available on the marketplace at some point in time. And I'm not sure what else is going to be. I think what Malachi did as well.
Perfect, perfect. All right, Malachi, you're live.
You're muted, Malachi.
You're muted though, yes.
Hello.
Hello.
Muted. Okay, so I was basically in charge of helping Saga solve the growing buildings. So we started off playing around with cubes, which are the ones that we have here, and the idea was that I think the underlying behavior behind this was something that Chris Murphy did, where you have a cube and it automatically populates the cube with different rooms. All I did on top of this was add a bunch of other functionality like custom blinds and facades, and I just took the underlying behavior and just added a bunch of stuff on top of it. And then the whole idea for this was that eventually we would be able to scale these guys up. If I can find my sequencer over here, was that we could scale these guys up, and it would kind of feel like that the building was growing. But what we found was that although that they kind of worked from like an up close perspective, and like maybe looking up, in terms of a vista, they actually wasn't that interesting. So we didn't end up going down that path, and they were actually never used. So then kind of going further, we were looking at some of the concept art that was sent over by the director, and he had this kind of idea where he wanted to have a building grow from wireframe into like a UV tile into the final material. So I created this kind of free material blend material. So it kind of there are three materials within one, and it's just kind of like blending between them. And this actually did make it into the final. But when we were kind of looking around the whole scene, we felt like it needed more to it. This effect on its own, I guess, wasn't interesting enough. So going back to the video that Saga then had, he showed this kind of like self-building that wasn't really shader based, but was actually mesh based. And what we didn't want to do is bring this in as like a FBX animation. We wanted to have this feel like that that we could do it on multiple types of buildings relatively quickly. And also just from a performance point of view, we thought it might be better to do something cool inside of a shader. And I knew that there was something called Pivot Painter, but I hadn't really delved into it. And a lot of the documentation was really for foliage and not really for rigid body stuff. So I got on the phone to John Lindquist. He's the author of the Pivot Painter tool, and yeah, he really helped me kind of build like the basic bare bones of kind of what this effect became. So for those who don't know, the Pivot Painter is a two-part tool. It's a export script from 3ds Max, and it is functions, just a few functions inside of Unreal. And basically, what it does is that it takes the pivot positions that you set, the pivot positions and the forward vectors that you set inside of Max, and bakes them out into textures, which are right here, and then using these guys. So you got a decode position, and you have another one for decode axis. You can have access to all of the pivots of the sub meshes inside of your meshes. And then if we play this through, you can see that what we're doing inside of the vertex shader is that all we're doing is that we're just scaling and rotating and scaling and rotating and scaling and rotating. That's all we're doing. And you can wrap this up into a function, which is what I ended up doing. So if we look here, what we're doing is we've got a pivot start position. And that is so that later on in a blueprint that I could actually assign a widget so that I could change where the effect started from. And then we're just getting the distance from our start position to each one of our pivot points. And then we're basically just creating a gradient, and that gradient based on where it is between 0 and 1, because we're saturating down here. Basically tells you how rotated and how scaled you are. It's super simple. And so like once we had that concept down and everybody was kind of happy with it, it was really easy then to kind of take it on and then build it into a blueprint. Again, I'm using a data asset as well. So the data asset is all of these materials. It's the all the different textures. So because there are actually two Pivot Painter buildings in one for the inside and one for the outside. That's just so that I could control the how fast the inside grew versus the outside. And so it's just really nice, just plug and play for artists, because you kind of have these config files where you have different skyscrapers just have different files, just have different config files, so they're not having to worry too much about setting up all of the inside bits, like what materials that go where. But it was really simple to just plug into any kind of material which you have now. So by collapsing it down into a function, it just was something that you could just put into like a crazy busy shader network that we'd already created, and just put something in right in at the end, and now it's a pivot building. So this is how it ends up looking. Is that we start from this start point right here. If I just move that around, and because it's all done on the GPU, you can really look dev this to your shot, because if you don't like the way it's growing, you can just you can just quickly change your center. You can change your the animation distance. So a higher distance means that the effect goes slower, and a lower distance means that it goes quicker. And it's really, and it was really powerful for the when you hand this off to someone like Saga or Julian, who then place it in a scene and need to set dress with it, because it's just really quick. Then Saga he sent me some more screenshots from Doctor Strange, and he was like, the Pivot Painter building is really cool, but is there something else that we can do to add some variation? So can we have some ripples and things like that in here? So if I hide this, so then this is again, this is really simple. So then now, so if I open up the if I open up the material, essentially what we're doing is that we've got our ripple center, so that we can move where this ripple starts. And then what we're doing is that there's two types of ripples. So there's our large ripple, which essentially is just some mass that dictates the radius of two sphere masks, which you can see here, and they're just subtracted from each other. And then we just have a little bit of mass at the end that just sets its strength and its contrast. And then we just lay these up. So if we encapsulate them into functions, then we can just do the same thing twice with different parameters. And then we have the sine wave. So the sine wave offer these little kind of tiny ripples, which you'll see here. So you have, if I hide the strength for some of these, so if I zero that out and I zero the medium out here, then these sine wave ripples are continuous. So they're going to keep spawning until I tell them to stop. So we've got this small ripple spawn duration, which is just the amount of time that it takes before they start dying out. So I could set this to like to 5,000, and then we're gonna get more. We're gonna get more of them. So then those are. I kind of wanted to give the feeling that these bigger ripples are kind of giving birth and displacing into these smaller ones. So if I just bang these guys back up again to 30. So if I play this through now quickly, you can see that we start off with one big massive ripple, and then as that dies off, we have our second medium ripple, and then we've got our small little sine waves that kind of come, and they just add like this small little shimmer on top of it. So then we had to think about how we were going to combine those two effects, because we want to feel like that this building comes from nothing, and then this ripple comes out and kind of materializes the whole building. So if I hide this level, and we go into what the final effect looks like. Actually, sorry, I'd actually missed something. Sorry, let me circle back around. Sorry. A very quick thing that I didn't cover on this ripple over here is that there was another thing which I added, which is pretty cool. Is that so you can see here that that the ripple is bulging kind of the side of the building, which you might want it to do, but you might not want it to do. So then, like, to give power back to the artist to really look dev what this is doing. I have you can paint the red channel, and the red channel is going to exclude the ripple. Oh, hold on, let me go bring this back. So the red channel is going to exclude where the ripple can behave. So if I turn this off and I come to paint, and I just paint the red channel now, and if I just come in here, I can start painting away where this affects on here. I mean, that really gives power back to the artist, because it is a procedural effect, but there's this kind of nice hand painted look dev that can go on top to really kind of nail whatever the artist kind of thinks is most appeasing. So that is the ripple effect, kind of all wrapped up there. But now if we play that through, it's skipping on me a little bit now. Oh, okay, I'll go on to the next bit. All right. So close that down. The final piece. It's going to play correctly. So this is the final piece. This is the pivot painter folding and scaling effect that is being driven by the driven by the ripple. So that as the ripple goes out, it's helping the pivot painter shader along as well. So like one is leading the other. So the ripple is leading the pivot painter effect, and the pivot painter effect is happening inside of the ripple. And then you can just kind of see at the very end, you're getting that kind of little shimmer, which is coming from our sine wave. But I said before, I have a webinar next week that goes into the full creation of this. I've given you a very kind of high level look at this, but Wednesday next week, I get pretty down deep into preparing the mesh and creating the shaders and things like that. But yes, that is my section. That's my section done.
Awesome. Thank you, Malachi. And if you're interested in watching that webinar, there will be a registration link in the forum announcement post. I'm not entirely sure if it's live yet. I think it is. And so if you are curious about that, I will go ahead and make sure that I post that link in the forum announcement post, which you can find on the Twitch About page, as well as in our event section of the Unreal Engine forums. And with that, I think we're all done with the presentations. Would you all be okay diving into a couple of the questions that we received?
Yeah, let's go for it.
Cool. Let's go to my right notes. All right. So some general questions about the project itself. Feel free to chime in if you feel inclined to answer. How many people and how many days, an estimation, parentheses, did it take for this project?
So start to finish, I would say it was about 3.5 months in total. And we started it just when the lockdown started. So it was a massive challenge of everybody being remote all over the world, people who didn't know each other working together remotely for the first time. Besides the 4 of us at Epic London, there was a team of at least probably 20 people overall at the mill, in and out, probably even more, working on the entire project. And then also a ton of really amazing, talented guys from special projects and various teams across Epic jumped in. So I would say maybe an additional 6 Epic artists also jumped on board this project at some point in various bits. So maybe the total number would be 40 people, 3 months.
There was another question came in that was, what kind of camera rigs are they using?
For the live action shoot.
I'm not entirely sure. This is why I try to ask everyone to provide details, because when we get to this point, then it's like, which section was it? Maybe you can answer sort of generically to the question.
I'm not exactly sure. I actually have no idea what they...
I think it might have been what kind of rigs, either in Maya, Unreal, how was the cameras sort of rigged to be animated in Unreal?
We pretty much did all of the camera work in Unreal, at least for the CG stuff. So there wasn't any like importing of Maya cameras or anything like that. It was pretty much 100% Unreal camera work.
Awesome. That must make it a little bit easier to iterate, right? Because you don't have to go between the softwares. You can just tweak it right there.
Absolutely. Yeah.
This is a good question. How do light maps get managed for such large geometry?
So there's only a couple of sections that had baked lighting. The museum section that the robot runs through was using baked lighting from a skylight, and I think the directional light was probably movable in that scene. But otherwise, it was a ray tracing project with fully movable lighting, so the whole city was dynamically lit. Our whole sequence was dynamic lighting with 0 light maps. So this was a very big test for ray tracing and also movie render queue.
Yeah, and maybe to give a little bit of detail there, when you actually render the movie out, it is done in sort of a sequence, right? You set it to which quality you want, and then it actually spits out, high quality imagery, close to real time, but not entirely, right?
Not even close to real time.
Okay, maybe not in the quality for this video, yeah.
Yeah, we rendered it at 4K, and we turned up all of the movie render queue samples really, really high to get really, really, crisp anti-aliasing. So sometimes some of the frames would be like half a minute to a minute per frame, per 4K frame. And Yeah, so this, I think 425 was the first version of Movie Render Queue, so this was kind of a really nice test case for the kind of render quality we could get out of that as well. It was a big improvement over the motion blur from Sequencer, and yeah, I think we benefited a lot from that.
In the plane twisting shader demo, are you doing tessellation or generating the mesh dynamically, or is it just a very dense mesh?
It's a very dense mesh. I mean, for the ground, we had a 100 by 100 grid cube. So it was 100 by 100 triangles. And for the buildings, they didn't deform, so they were basically straight, so we didn't need to do any extra tessellation.
How does one learn to do shader deformations?
I think the first thing will be to start playing with the work position offset. There are some really simple examples in content examples. You can see a few examples where they have like even just to move the object a little bit without deforming it, just adding the same value to the deformation that would move all the vertices at the same time, and that will give you a sense of how it works. And then you start working with each vertex individually, which you normally use the position of the vertex. That's probably the only data you have to make it different, and then start playing with it. The good thing is that if you have like zero mesh deformation, you will see the mesh as it is, so it won't crash or do anything weird. And if you have an effect, you can always multiply the effect by a very little number, and then you have the effect more or less controlled. Even if it's breaking the mesh, you get a lot of broken meshes and all the triangles all over the place. But by multiplying the effect, you can always see how it looks and how it works, even if it is very little, and then you can start playing with that.
Tweak, 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 and keep tweaking.
Yeah, that's why it's important to have the parameters always saved, because there's so many parameters you have for these things. So you need to start using systems like data assets or material parameter collections where you have all the parameters together, and then you can basically make a copy of that and then start modifying the parameters, because there's so many of them that at one point, if you start messing around, at one point you lose what you had before. So it's always good to keep a copy of the parameters and be very organized with them.
Version control, everyone. It will save your life, or at least your work life. What GPUs were you using for such big scenes?
Kind of all over the place, but 2080 Ti's, I think, for us, our team.
Mostly that, yeah. So pretty consumer grade as it goes. You know, it's not like we were using crazy quadros. We were just high-end consumer cards.
According to
my personal PC, no office machine, so consumer grade for sure.
according to Richard Cowgill that was on the stream, he actually now said that even the 2080 Ti's are now considered the lower end cards.
Yeah.
Which is a little sad for us who's sitting here thinking like, oh, I'm at the top now. Like I finally got my my ultimate card, and then they come out. It's like, oh, okay, all right, time to upgrade, I guess.
Yeah.
Let's see here. Are there any examples of using Niagara for procedural particle effects?
What do you mean by procedural particle effects?
I think during your presentation, Carlos, you mentioned a procedural way of sort of moving. I'm not 100% sure if that was the question was referring to, because almost all of them are procedural in a way, right? Unless you specifically...
Yeah, kind of. I mean, basically what we were doing is, instead of doing the usual particle system where the particles have velocity and then the forces act over the particles over time, and gravity pulls the particles down and drag slows the particles. Basically, we were taking the particle position and we were calculating it from scratch every time without using the previous position. That's the only difference that we were doing. I haven't seen that done before, but since this was what the effect required, we basically switch the emitter to have the particles always on without having like them being spawned and then dying. They're basically all the time there. And the lifetime of the particle is looping. So it's always going from 0 to 1, 0 to 1, the normalized age. And that gives us a parameter that we can use to start moving and then going back.
Yeah. Also, circling back to shader deformation shaders. Ryan Brooks and I emailed Ryan Brooks before I was able to work at Epic, and he pointed me in the direction of Scratch a Pixel. So passing that on down the line, Scratch a Pixel is a really good tutorial website to use.
Ryan Brooks is actually coming on the live stream next week. He's going to talk about water and volumetrics related to 426. Some of the stuff he's been sort of teasing and showing off a little bit at Unreal Fest Online. Yeah, it's always exciting, right? I'm happy when I'm able to ask the question and he just goes like, yes, that date works. I'm like, all right, cool, ship it. Were the transitions between shots handled in Unreal or edited in post?
They were handled in Unreal. As much as possible, we wanted to do everything in Unreal. So the transition from the architecture to the automotive sequence involved the car door going past the frame. And so the challenge there was just making sure that the animation of the car and the cameras lined up from one level to the next and to get that kind of seamless swoop effect. Probably the most difficult transition was one that a technical artist at Epic called Marian worked on, which was the dust particle balls transitioning into a sand effect that kind of took you from the museum out into the desert, and that's 100% done in Unreal as well. So yeah, we made sure to do it all in Engine, and a lot of the work was amazing that the guys did.
And that's sort of where we're moving, right? Trying to stay within one software as much as possible to limit all of the problems that come up when you're working, with one format to another, one software to another. And that's what's really cool to see, that so much of the content that's now being produced with Unreal, it's almost all of it is done with Unreal. And especially when you put that together with the ability to now use control rig to either procedurally animate in Engine and then combine that with the in-editor modeling tools that are being developed. It's like, oh, I guess this is where I live now.
But the final edit was made by the Maildor, which obviously was not made in Unreal. So the final product is not just one long Unreal sequence.
Yeah.
So, Saga, you could talk about how you overcame some of the ray trace translucency issues on that first shot with the gloss. Second shot, sorry.
Yeah, I mean there were certain shots that needed a couple of render passes to get everything in, because we wanted to take advantage of ray trace translucency for the glass. There are certain limits to ray trace translucency where we couldn't get the card sprite sheets of the atmospheric fog in the city along with the interior reflections from ray trace translucency in the glass in a single render pass out of Unreal. So I had to do a couple of render passes, one with ray trace translucency and one with rasterized translucency, and deliver both of those passes to the mill, and they combine them together. But we kept most of that to a minimum. There was a couple of really complex situations like that involved 2 render passes.
See, it was not mentioned in the presentation, but was there any keying involved in this project inside Unreal? And here's some details. Or was all the green screen keying done outside and imported?
So we played around a little bit with the keying tools in Unreal just to be able to clearly see the plates in Engine with the environments behind them. And you can very easily key stuff in a shader in Unreal just by masking colors and things like that. But the final keying was all in post in Nuke, and I think they also used Flame for some of their comping. So we didn't take advantage of Composure or anything for live comping in Engine. It was all in Nuke and Flame.
Let's see if there are any. We're actually short on time, so I think this is, I'm going to get to my last question now. And it was just someone wondering in general, and I think maybe y'all, each and every one of you can answer this. What technology over the last 2 years have been so exciting that you wish you had more time to dive in?
Probably Chaos for me.
I would say Niagara. So much you can do there.
For me personally, it would be learning Houdini and just seeing what's possible. I really want to get into that mindset to create better art and faster. I think it's going to change the industry, and it's really important for anyone who starts to get a good grasp of Houdini.
Yeah, there's a lot of connectivity now between Houdini and Unreal as well. A lot of
Yeah.
people creating effects and importing Niagara or even Houdini engine.
Yeah,
Yeah, but even for artists, like it's just even my presentation was about Quixel, but in the end, the goal is to produce better quality faster, and that's exactly what Houdini is made for. You make one node system, and then you just replicate and you produce art super quickly. So teams of, like in the video game industry, the teams are not growing in terms of numbers, so you've got to cover big environments with the same amount of people, and the way of doing this is to automate tasks, where Houdini is very important. So yeah, Houdini all the way for me.
If you're, I'll get to do. Sorry, I just want to do a little brief mention that we actually had Quixel on the stream last year, and they covered Quixel and Houdini. Paul Ambrosiusen from Side Effects was here, and he actually showed how they used Houdini to develop the environment art used for last year's GDC cinematic that we produced together with them. And that live stream is a really great breakdown of precisely what Julian is talking about, that mindset of, right, how can we automate this to produce things quickly and still have all the options to change, from the perspective of the director. It's a lot of work if you tell an artist, move that a little, all right, okay, remodel, export again, right? Whereas in Houdini, it's you change a parameter, poof, and it's inside Unreal, immediately, and you can look at it.
But
Please.
at the same time, it's super easy to get overwhelmed by Houdini and try to do everything with that tool. And I have done with a couple of people with just Houdini freaks, and in the end, they were trying to make a simple lamppost in Houdini when in Maya it takes you 20 minutes. So it's a balance to find, I guess.
I would say there isn't really like any one software that I wish I learned. I mean, I'm pretty sure we're all glad we chose to get really good at Unreal, because Unreal is taking over the world, it seems like. But I would say I wish I had thought of Quixel, and I wish I had thought of Kitbash, because I mean, especially now Kitbash has got Unreal kits. So just the ability for smaller and smaller teams to create massive worlds on their own, what used to take huge teams of people, I think now a really small studio or a couple of guys can put together. The only problem is a lot of generic looking stuff out there, with everyone using the same libraries, the same resources. It gets more and more challenging to stand out and be unique, and I think that's where the customization comes in.
There's one last question that came in. Can you ask if there was any real-time green screen removal in the project?
No, I think this kind of goes back to the keying question. There wasn't really, other than just for our purposes of visualizing the plates in engine for placement and stuff, but nothing sophisticated.
Awesome. With that, I want to thank you all for coming on and showing, showing off what you did in the project. For everyone who's excited to know a little bit more, Malachi will be doing a webinar next week. I believe the link has been posted in chat. I think we can get it pasted one more time. And so thank you so much for taking time out of your day to prepare for this. It's been a pleasure. I'm really excited to see all the amazing work that you've done, and also to get to hear a little bit about your perspective on the project and what's happening. If you are interested in to know more about all of these amazing artists here, you can find their ArtStation handles in their little lower thirds right down here. Actually, I have my Twitter, but they got, and then Carl's webpage is there if you're interested, or if you want to get in touch. With that said, next week, I mentioned it earlier, we're going to have Ryan Brooks on the stream. He's going to talk about water and volumetrics. I am really excited about that. I would also like to mention that all of our live streams are captioned, sort of automated and then manually, which means that if you aren't sure what one of us said or the terminology, how to spell it, and you want to know how to Google it, within a week after this video goes up on YouTube, we generally post a link where you can download the entire transcript. And it's a really good way to go download the transcript, go Control F and search for either key terms or just scroll down. If you know in the video, it was mentioned at the 23-minute mark, for example, there are timestamps in the transcript. So you can go to that timestamp and see what was said, or just on YouTube, turn on the captions, which really helps. Same thing if you're here from the beginning, you watch the entire stream and you're like, oh yeah, they were mentioning about like deformation. I don't know which timestamp, and you sort of want to look specifically at what Carlos did. You can go ahead and maybe Control F, search for Carlos, and you'll find one in the beginning when I introduced him, and then another one a little bit later in the stream when I told him that it was time to go. So it's a really good way to sort of be able to consume the streams a little bit faster, because I know that there's a lot of content here, a lot of things are being said, and it can be a little bit difficult to go back and find them if you just have the stream. So check out the transcript. Also, big up to Courtney for doing the transcript every week. If you are interested in being part of our News and Community Spotlight, make sure you let us know the projects that you're working on. A good place is the release section and the work in progress section on the forums. You can also post in our unofficial Unreal Discord, Unreal Slackers, unrealslackers.org. A great place to hang out and talk to people about Unreal. There are several thousands of very talented developer and artists hanging out there, and it's a good place, especially now since we're all working from home, difficult to meet other developers in the world. Unrealslackers.org, check it out. If you are streaming on Twitch, make sure that you use the Unreal Engine tag. I generally combine the Unreal Engine tag with the game development tag, and if you are interested in seeing who else might be streaming content on Twitch, you can go ahead and filter for the Unreal Engine as well as the game development tag. Two good options. Make sure you follow us on social media for all news Unreal. And I think with that said, like I said, next week, Ryan Brooks, tune in, don't miss that. And with that, anything else y'all want to leave chat with?
Maybe if you leave out the final video, Victor, if you want to play the final video as we lead out, if there's time.
Absolutely. I will end with the final video. I did see there were a couple of people who joined later in the stream, and so they didn't get a chance to see it. I will play the final video and then the outro, and hopefully I hope you all stay safe and have a great rest of your week and weekend, and we will see you again next week. Bye-bye, everyone.
Bye.
Creativity lies in all of us. It's what makes us human. It starts with an idea. The desire to create, to solve, to play, to share, to interact. Together we can build new worlds. Freedom to create for all.